Okay, so let's do another problem for potential energy. Here we have a child on a swing. Might be the top on attached to some tree limb, or the swing structure on the top. But it's anyway. This rope for the swing is hanging down, and there's a 40 kilogram child sitting on a swing. And the problem says that the rope length is 2 meters. So from the top to where the seat is 2 meters. And we want to calculate the potential energy of the child relative to this position, relative to the stopped position over here. So what's happening is, I'm going to do it in yellow so you see what's happening here. What's happening is the swing is going to be raised up 30 degrees. And now we have this situation where there's our kid over there. And we want to find out what's the new gravitational potential energy relative to this position right there. What happened to that? Okay. Did I want to do that? Okay, listen. Here, we'll do this. Undo. This, I should have made that dotted line, but now I can't do it, so I'm kind of stuck right now. All right. So anyway, so the swing is over here, and the kid is over here, and then someone pushes him up 30 degrees, holds him up there 30 degrees, and they want to know what is the new gravitational potential energy. Given that right here, we're going to say the potential energy of gravity is 0 right here, because it's arbitrary where you assign it. So you could assign it something from the ground, but in this problem they're saying, well, from where the kid is sitting right there, that's the 0 mark, and anything higher than that is going to be considered the potential energy we're going to be talking about. So they let us know that in the problem. So what we want to do is find out essentially this height here, h. If we find out this height h, then we know that our gravitational potential energy is mgh, and it's going to be 40, because that's the mass of the child, times 9.8 times whatever that height is. So if we get the height from the level position here to the raised position, if we get this difference right in here, that h, we will be able to plug it into our potential energy equation and find out what the new potential energy is from raising this child up through a 30-degree angle. So from here on, it's just a little bit of trigonometry. So let me see what we've got here. If this is 2, right, this rope length never changes. So what we've got is a situation here where we have 2 meters on the rope. We have 30 degrees here. And now if we draw the triangle, we're going to find, if that's a 30-degree angle and this is 2, there's for a 30, 60, 90, which everyone should remember for physics anyway. If this is 60, this is 30, this is a right triangle. If this is 1, this is 2, and this guy here is the root 3. If this is x, this is twice x, and this is root 3 times x. So this is the ratio or the relationship between the sides of a 30, 60, 90. If you don't know that, this is the hypotenuse, and you can say that to find this opposite side, we know that the sine of 30 equals opposite over hypotenuse, and you can find then what this side is, and then cosine will give you this side. But anyway, this will be 1 meter and this will be root 3 meters here. Well, this is the important part that I'm looking at, the root 3 meters right here, because what I want to look at is this piece right here. That's what we said was the height. Okay, this 1 meter, by the way, is not the height, it is this in here. Alright, so this is our height. So the height of the swing over here, you can see it up here where the yellow is, plus this piece right from here to here. So in other words, this piece right here. The height plus this piece, which in this case is root 3, is going to have to be the total of 2. Let's not get confused. Let's look at it this way. If this is 2 meters, and I go and I swing that 2 meter up, this is still 2 meters, right? I just swung it through an arc. Then I'll do yellow. Then this is the height distance that it was raised that I'm looking at. So I want to find how much did it go up. I need then to find this piece, because I know that this piece plus this height has to equal the 2 that I started with. Alright, I hope you see that. And then I realized that, well, we got 2 here, so this piece here was 1, and this piece here was root 3. So root 3 plus h has to equal 2. So height then is 2 minus the root 3, which comes out to 0.268 meters. That's how high it was. So then we're done. We just have to find the potential energy due to gravity. So it's the mgh, which is the mass is 40 kilograms times 9.8 times the height in this case, which we just figured out through a little trigonometry, little geometry there, and with little calculations, that comes out to 96.04 joules. This was one of the problems in the textbook, and I just thought it'd be useful to solve that for you. Okay, so next time we're going to talk about energy conservation.